HR Wallingford and UCL researchers are working to test the coastal defences and urban environments to tsunami resistance with the aim of improving engineering guidance and aiding disaster management worldwide. Dr. Ian Chandler is an engineer.
The simulator is designed to recreate tsunamis. The most important thing that we're trying to recreate is the length of the tsunami, so the period of that wave. Lots of other researchers have created waves in the past that are really too short to represent the tsunami. So the waves that we are generating are not particularly tall, but they're very, very long. And that's the important thing about our new generator. So it's a steel box with an outlet at the front. We have a vacuum pump on the top which draws air out, and then a valve that we control to let the air back in, and that controls the water level inside the tank and therefore the wave that we create in the flume. Because we have control over the air valve, we can modulate the signal and the way the water level changes, and that allows us to recreate the tsunami profile accurately. So we're not just dumping a load of water in or dropping a block in there to create an uncontrolled wave. We have complete control over the waveform that we're creating. So yes, it gives us the most realistic tsunami that we can model. The first things that we looked at was the run-up, so how far the wave moves inland, and we found a big difference between the really long period waves that we're generating here and the shorter period waves that everyone else has generated in the past, and the distance that water runs up is a function of the wave height, and is actually equal to the wave height for the very long waves. Whereas previous research has suggested that as you get longer, your wave height and your run-up would keep increasing, and that's something that we've shown not to be the case. What we're doing now is looking at forces on buildings, arrays of buildings, and also the forces on a coastal defence, and looking at the potential failure of that coastal defence and how that changes the forces on the buildings.
Professor Tiziana Rossetto is one of the researchers behind the testing and believes there is a way we can prevent the disaster.
Tsunamis can be created in different ways, some through landslides falling into a large body of water, but the most common is when an earthquake happens under the sea bed, at the seabed. When an earthquake happens in these areas called subduction zones, what happens is it displaces the water above, and that displacement of the water causes a wave of extremely long wavelength, of short amplitude, to propagate out from the fault zone. And it's that wave, when it comes into land, that it grows in height and basically becomes the destructive tsunamis that we've seen in so many videos. Tsunamis are devastating natural hazards, and when they happen, although rare, they affect an incredible number of people's lives, and they cause enormous economic losses. It's really important for us to be prepared for tsunamis, to be able to defend our coastlines, to be able to defend our coastal communities, and major infrastructure like nuclear power plants, which were damaged, for example, in the last Japan event. Since 2004, the number of lives lost to tsunami, which is just under 300,000 people, is equivalent to the number of people who have lost their lives through car accidents in Europe. So that actually sort of puts it into perspective as being, a major natural hazard. The simulator here gives us a unique capability of studying tsunami waves. It's the most realistic simulator of tsunamis. It generates these extremely long waves, which show very different physics from the shorter waves that are generated by, say, wind. And what that is giving us is information on how we calculate the forces on buildings and how far inland a tsunami will inundate, and all of this information is giving us, is helping us to guide the construction practice as well as evacuation procedures.
Scott Morgan for That's Oxfordshire.